wanted to share a program that I've been working on called the Attestate crawler, and it's actually running here in my shell right now. And yeah, it's essentially a crawler that allows you to download any kind of on-chain data really rapidly. And so you can then, that data is then stored in LMDB and you can query it. So for example, here I have like a bunch of the catalog NFT contracts, minting events. So these are actually the transaction IDs. And yeah, you can see this is like NFT 697 that is being minted. Now, actually, all of this is like stored in the data repository. There's like this load folder. Then there's like an extraction folder that contains like a bunch of flat file like JSON data essentially, and then we also have like a transformation folder. And so essentially this is like an LMDB, and these are two flat files. And I can, in essence, I can delete this folder, and I can just run the crawler once again. You can see it like shows all of these messages, and then when we look back into into like what it extracted, it basically returns kind of the same thing. And this is essentially the raw data that we're crawling that then eventually ends up like being loaded into a database. Now, the config file here is something that you're supposed to configure, and that's very similar to like the subgraph file that you have in the graph protocol. And basically we are defining the range of blocks that it should mint. So this is actually the starting point of the catalog contract. So if you look into the deploy transaction, oh no, it's wrong. It's like some other kind of like number anyways. Then we have a step size. We have the address of the contract, which I think should be that one, right? Yes. And then we have topics. So this is actually the topic for a transfer. So if we look into the logs here, it's actually the transfer topic. And then we say the from address needs to be the zero address. So we're only looking for mints. And then you can see how all of this works. I'm basically calling a strategy, and I'm calling to extract a certain amount of data. So within that range, for that address, these topics, and that step size. So the step size is essentially the amount of blocks that we're stepping over in each iteration. Then we are transforming what we crawled. I honestly think we're not doing anything at this point, but this would be useful if you need to filter if you need to do like more in-depth filtering, or you need to, for example, like parse NFT data or whatever. And then in the end, we are loading this into LMDB, and then here are some like other options, like we can do rate limiting, or we can also define the concurrency of the crawler itself. So again, like I can delete this data. I mean, we're not downloading that much, but it's fairly quick. It's like a few thousand blocks. And I then have a command line interface that I can use to access LMDB. And LMDB is actually thread safe. So you could have this, also run in parallel, essentially, like continuously keeping up to date with the Ethereum blockchain, and then still also query like the database that it's currently writing. That's the kind of the point with LMDB. So like a project like Aragon is, for example, using that. And so what this allows me to do is actually I can request a range of values from the database. And so this is the database itself, and then I'm basically calling this sub database, and I'm trying to get the order. So this is ordered, as you will see. This is actually ordered by the every event gets ordered by the block number and by the transaction index of its transaction. So you can actually see that this is kind of like in one block, right? and it's like, it's this transaction index, and then that's the transaction. So you can actually see that uh, in the block explorer now. Okay, that's a bit confusing because I'm still in this tab. But so you can see that this is like 697, and so like this should actually 698 actually. So let's quickly check that. Yeah, so that's correct. So essentially, like this whole thing gives us an ordered log of all of the events that happen in the contract. We can, and then we also have direct access actually to the log receipts itself. So we can also query directly for a value. Ah, no, that didn't work. I think because it's a range call, I haven't built the direct call, but we can get all of the events here, and so you can see that these are all, and then you can see that we are also having as an entire key like this value in LMDB that you can also query. And so the point with this program is really to have something like a GraphQL that you can use in a peer-to-peer application, and that you can tightly integrate into your application, where you would be running this crawler kind of like as a separate process, and then at the same time your peer-to-peer application would access the LMDB instance, and it would like use all of this on-chain data to quickly react and show the users uh, like whatever kind of process data. Like a similar application like this has already been used to condense all of the music NFT tokens and list them as unique keys on like a music player similar to Spotify. And I think, yeah, apps like Farcaster, for example, could also profit from implementing a crawler like this that continuously runs and has like thread safety built in. Um, because the benefit of that over, for example, downloading all of the data over the network, is that it's just really fast. And since like I'm not even, like I don't even have like an Ethereum node running here. So I'm going over the network, but imagine if I would co-locate this with an Aragon node, I could like do really fast processing of the entire Ethereum history, because I just go to disk essentially with the RPC daemon of the Aragon project. Yeah, so that's it. That's the crawler. You can check all of this out actually at attestate.com, and then there are like we have basically a bunch of docs. All of this is like still in development, so bear with me as I'm trying to fix stuff. But we have some strategies that you can use, kind of like a bunch of docs. And yeah, it would be lovely to see you there and to contribute or try it out. And yeah, also tell me what you think of this. Is this useful? Yeah, thank you.